Hello everyone, welcome to this free CCNA course. This is part 2 of day 1. My name is Ahmed Inaya and in this video I will talk about LAN, WAN and Ethernet. Let's start by talking about types of networks. Networks can be used to connect users in the same location over wired networks, and in this case this is called LAN or local area network, or it can be used to connect users in different locations, usually far away from each other, and this is called WAN or wide area network. Network can be used also to connect users in the same location over wireless, and this is called wireless LAN. In the coming days, we will talk in details about LAN, WAN, and wireless LAN. Network is used usually to connect users to different services. This service can be internet, cloud, on-premise data center, or any other local or remote services. There are different devices used in the network for different functions, and these devices operate at different layers of TCP/IP model. TCP/IP model was discussed in details in the previous video. So let's talk more about types of networks and network devices. Let's start by a small network that consists of two PCs or two devices and printer. So this small network is used to connect these small devices to this printer to provide printing service. This is a very simple service, and let's assume this is in one building, in one floor, which is floor 1. In these networks, where only local services are needed and there is no need to connect to the internet or remote services, we usually use a device called a switch. A switch is a network device that connects hosts or devices in the same area or same location to services in the same location. They operate at layer 2 of TCP/IP model, and we will discuss the switches in more details in the coming videos. Now let's assume this network expanded and we have another floors, floor 2 and floor 3 in the same building. In this case, we need a switch in each floor to connect users in that floor to services in the same floor. Now how about connecting devices in different floors to services in different floors? In this case, we need to connect these switches to each other by using a larger switch, usually called distribution switch, or sometimes we call it core switch. We will discuss these terms in more details in the last day, day 5, when we discuss network designs. The switch that's used to connect devices in the same floor is called access switch, and this will be discussed also in more details in day 5. This network that consists of cables and switches in the same building is called local area network or LAN, which means a network that connects devices and services in the same physical location. LAN usually uses a protocol called Ethernet or IEEE 802.3. IEEE stands for Institution of Electrical and Electronic Engineers, and we will discuss IEEE standards in more details in the coming slides of this video. Ethernet can be defined over different types of cables. For example, it can be defined over UTP, which stands for Unshielded Twisted Pair, but UTP is limited to 100 meters. Ethernet can be also defined over fiber, which can be multi-mode or single mode, and this can go for larger distances. We will discuss Ethernet, UTP, and fiber in more details in the coming slides of this video. Now, how about if we have these devices in different floors in different subnets? We will discuss subnets in more details in day 2, but for now, IP subnet is a way to group devices into logical partitions, and in this case, we need to have a router or multi-layer switch or layer 3 switch to connect these subnets to each other. We will discuss routing and layer 3 switching in more details in day 2 of this course. Now, let's assume in this building we have a central servers which are connected to floor 1, for example, and connected directly to layer 3 switch or core switch. And let's assume we have a remote branch that needs to access servers in this central location. So this is central location or headquarter, and this is a branch. We have a switch and we have a LAN in this branch, but users in this branch needs to access resources or servers in central location. In this case, we need to have another type of network, which is a WAN. WAN stands for Wide Area Network, and in this case we need to have routers to connect WAN links between remote branches. Typically, we use different protocols for WAN. For example, we use HDLC or PPP, And in some cases, mainly recently, we start using Ethernet for WAN connectivity. We will discuss LAN and WAN in more details in the coming slides of this video. Before going into details of networks, let's discuss network speed. Computers usually store data and information as zeros and ones. This is called digital, and every digit is represented by either 0 or 1. In numbering system, this is called binary format, and we will discuss binary format more in the coming slide and in more details in day 2 of this course. Usually, network speed is calculated in bit per second, so we have 1 kilobit per second, which is 1000 bits per second. We have 1 megabit per second, which is 1 million bit per second. This is 1 and 6 zeros. The next digit is gigabit per second, which is 1 billion or 1 gigabits per second. This is 1 and 9 zeros. The next digit is terabit per second, which is 1 and 12 zeros bits per second. And as you can see from this table, 1 megabit per second is 1000 kilobit per second, which means 1000 times 1000 equals 1 million. The same way, 1 gigabit per second is 1000 megabit per second. 1 terabit per second is 1000 gigabit per second. And for comparison only, data stored in computers is measured in byte, and 1 byte is 8 bits. So when it comes to link speeds, we usually measure it in bits, but when it comes to data storage, we measure it in byte, and every byte is 8 bits. Before going further into discussing networks, let's discuss one important subject, which is binary, decimal, and hexadecimal numbers. As we discussed before, computers store and send information as zeros and ones. This is called binary number system or base 2. It includes 2 digits only or 2 numbers, which are 0 and 1. These are the only digits used in computers, and all information are stored and sent by computers using these 2 digits only, which are 0 and 1. There is another number system, which is decimal number system or base 10. This is the one we use in our daily life. It includes the numbers from 0 to 9, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the numbers we learn in school usually and we teach our kids, and these are the numbers we use to calculate in our daily life. There is another system, which is hexadecimal number system or base 16. It includes the numbers from 0 to f, where f is equivalent to 15 in decimal. This table shows the conversion between different number systems, decimal, hexadecimal, and binary, for the numbers from 0 to 15 decimal. So 0 in decimal is 0 in hexadecimal, and it is 4 zeros in binary. 1 in decimal is 1 in hexadecimal and 001 in binary. And when it comes to 10, 10 in decimal is A in hexadecimal, and it is 1010 in binary. And 15 in decimal is F in hexadecimal or 1111 in binary. We will discuss the conversion between these systems in more details in the coming videos. But for now, it is enough to have general idea about these systems because they are used to represent different addresses in computer networks. Now let's talk about Ethernet standards. As we discussed in the previous slide, Ethernet is the protocol used in local area networks or LANs, and Ethernet is defined in IEEE 802.3 standard. IEEE stands for Institution of Electrical and Electronics Engineers. IEEE is the institution or organization that creates standards for different computer network protocols. These standards are built for manufacturers to follow and to comply with to provide interoperability between different vendors. Interoperability assures that products from different vendors can work together in the same network and can provide expected features and expected functions while working together in the same network. And that's why it is important for any manufacturer to make sure that its products are fully compliant with IEEE standard before selling its products in the market. Ethernet defines standards for sending data over different media types like UTP, which is unshielded twisted pair, and fiber. We will discuss UTP and fiber in the coming slides in more details. Ethernet works at layer 1 and layer 2 of TCP/IP model. This is physical and data link. Most network devices support Ethernet, mainly switches, hubs, and bridges. Nowadays, switches are the common network devices. Hubs and bridges are old devices that are not commonly available in these days. So for us, we will discuss mainly switches in this course. When communicating over Ethernet media, devices use MAC addresses, which is Media Access Control Address, when communicating with each other at Ethernet or data link layer. MAC address is a 48 bits or binary number, and this is represented usually as 12 hexadecimal digits, as we will see in the coming videos. So in TCP/IP model, Ethernet usually works at these two different layers, which are physical and data link layers. Now let's start talking about Ethernet over UTP cables. UTP cables, which is unshielded twisted pair, is a copper cable. It includes 4 pairs, which is 8 cables. Each pair is 2 cables. Only 2 pairs of these 4 are used when communicating over speeds like 10 or 100 megabit per second, but all the 4 pairs are needed when communicating over speeds like 1 gigabit per second and higher speeds, as we will see in the coming slides. Ethernet is color coded and each pair is twisted. So for example, as you can see here, each pair of these 4 is a twisted pair, and it has different color to be easily identified from both ends of the cable. Why twisting each pair? These cables are radiating some power, and by twisting each pair, we can reduce this electromagnetic radiation by each cable cancelling all or most of the radiation of the other cable. Crosstalk is a term that's used for interference from one pair to another, and by twisting these cables, we are minimizing crosstalk or eliminating a crosstalk between these pairs. When it comes to connecting these cables to different devices, we use usually RJ45 connectors, which are the common connectors used in PCs, switches, and routers. And if you have any cable connected to the network, you must have seen this connector before. As you can see, this connector can terminate 8 cables by using this connector type. There are multiple standards defined by IEEE for Ethernet over UTP or over copper. So for example, we have old 10 megabit per second. This is somehow an old protocol that was defined in early day of networking. The IEEE standard name for this speed is 10 base T. T means UTP, and 10 is the speed for this link using megabit per second as a unit. Each standard has a name as part of 802.3 suite, and the name for 10 base T is 802.3 itself. Usually, the common name for this standard is Ethernet. 10 megabit per second uses only 2 pairs out of the 4, and the distance is limited to 100 meters. The next standard has a speed of 100 megabit per second, and it is called 100 base T. And again, 100 is the speed in megabit per second, and T means UTP. The name for this standard as part of 802.3 suite is 802.3U, and the name used for this standard is Fast Ethernet. This standard uses only 2 pairs out of the 4, and it is again limited to 100 meters. The next standard is 1 gigabit per second, which is read as 1000 base T. 1000 is the speed in megabit per second, and T means UTP. The standard name is 802.3AB, and the common name is Gigabit Ethernet. At this speed, all 4 pairs are used, and distance is still limited to 100 meters. The next standard is 10 gigabit per second, and it is read as 10G base T. So 10G is 10 gig, and T is UTP. The standard is 802.3AN, and the name usually is 10 gig Ethernet. Sometimes it is written as 10 gig in some switches. We need to use 4 pairs at this speed, and distance is limited to 100 meters. The good thing about Ethernet is that the speed can be negotiated between both ends, and in most cases, you'll find the speed of the ports is auto 10, 100, 1000 megabit per second, and even 10 gig ports can negotiate the speed that can go to lower speeds when needed. We will discuss auto negotiation in the coming videos when we talk about switching and Ethernet in the lab. When it comes to cable pin assignment, We have two types of cables in Ethernet, straight through and crossover. We have 8 pins or 4 pairs in each UTP cable. So let's assume we have one of these devices in one end, which is a PC, router or firewall. For these devices, PC, router and firewall, they are sending data or transmitting data over port 1 and 2, and this is called TX. TX means transmit. So these devices transmit data over pin 1 and 2, and they receive data over pin 6 and 3. So 1 and 2 for transmit, 3 and 6 for receiving. RX means receiving. On the other end, let's assume we have a switch. Switches have different pin assignment. Switches use pin 1 and 2 for receiving and 3 and 6 for transmitting data. So if we have in one side this type of devices and on the other side we have switches, in this case we can connect the cables this way, 1 2 to 1 2 and 3 6 to 3 6. In this case, devices can send over this pair from this side to the other side, and when switches want to send data to the other side, to PC, router or firewall, they send data over port 3 and 6. These pairs are half duplex, which means they can only send or receive at any time, and that's why the transmitter must be connected to receiver on the other end, and receiver from one end should be connected to transmitter on the other end, as the data can flow only from transmitter to receiver in half duplex format. This cable is called straight through cable, and the pin assignment is 1 2 is connected to 1 2 and 3 6 are connected to 3 6 on the other side. Now how about if we have the same setup again, but in one side we have a switch and on the other side we have a switch also. Let's assume we use the same cable with 1 2 3 6 connected to 1 2 3 6. In this case, switches use pin 1 and 2 for RX and pin 3 and 6 for TX. So if these two switches wants to communicate over this cable, both of them will try to send data over pins 3 and 6, which means they will never be able to talk to each other because they are sending over the same pair and they are not able to receive over the same pair. This will never work and communication will not be established this way. To solve this issue, we need to change pin assignment for this cable. So let's try to connect 1 and 2 to 3 and 6 and 3 and 6 in this side to 1 and 2 in the other side. This way we have TX in one side connected to RX on the other side and TX in one side connected to RX on the other side. And if devices try to communicate this way, TX from side A sends information over 3 and 6 to RX on side B over pin 1 and 2. And when this side B wants to communicate with side A, it sends information over pin 3 and 6 to the receiver pins on side A, which is 1 and 2. This cable with this pin assignment can be used to connect switches to each other. Now let's assume we have different setup. Let's assume we have PCs, routers and firewalls on both ends and they need to communicate with each other. And let's assume we have the same cable with 1 2 connected to 1 2 and 3 6 connected to 3 6. In this case, we have TX or transmitters in pin 1 and 2 on both ends and receivers are in pin 3 and 6 on both ends. If these devices want to communicate with each other, they'll try to send data over the transmitter, which is pin 1 and 2, and both devices in both ends will try to send data on the transmitter pins, and this means the data will collide and information will never be received on receiver end of both sides. So again, as we did in switches case, we can connect the cables this way and this way. Transmitter of one end is connected to receiver on the other end and receiver in one end is connected to transmitter on the other end, and information can flow this way from transmitter to receiver as it should be. This cable setup is called crossover cable, and in this cable 1 and 2 are connected to 3 6 on the other side and 3 6 in one side is connected to 1 2 on the other side. These types of cables are needed for Ethernet standards that use only two pairs, which are 10 megabit per second and 100 megabit per second. But when it comes to higher speeds like 1 gig or 10 gig, it is totally a different story. For higher speeds like 1 gig and 10 gig, all the 4 pairs are used in this case, and they are all full duplex, which means all pins or all pairs can send and receive data at the same time, and they must be all connected at the same time. All these pairs are used full duplex to send data at speeds of 1 gig or 10 gig. Now in new switches and new devices, there's a feature called Auto MDIX, which means new network devices are intelligent enough to understand the other side of the connection and to modify TX and RX pins based on the setup on the other side. We will discuss this in more details when we work on the labs of Ethernet, but still it is a good idea to understand pin assignment of different cable type. Now let's discuss fiber and Ethernet over fiber cables. Fiber optic cables use glass to pass light signals between one end to the other. This fiber can be single mode, which means it uses single angle when sending information from one side to the other. Single mode fiber uses usually laser for transmitting and receiving, and as any fiber cable, there should be cladding that protects the core of the fiber from the environment. In single mode fiber, the core is very small and data is sent using laser over one angle, and that's why it is called single angle or single mode fiber. Single mode fiber can go for longer distances than other types of fiber. The other type of fiber is multimode or multiple angles, which means the light is emitted using LEDs at different angles, and usually the core in multimode is larger than the core in single mode. In all cases, there should be cladding to protect the core from the environment, and this core part is very sensitive and can be easily broken. When laying fiber for long distances, usually fiber cable includes many cores, and this core sometimes is grouped and protected by multiple layers of protection to avoid any damage to core part, which is very sensitive. For connector type, there are many types of connectors when it comes to fiber, but the most common connectors currently are SC and LC connectors. When it comes to IEEE standards, we have multiple standards for fiber, so these are some of the common standards when it comes to Ethernet over fiber. At 1 gigabit per second, we have 1000 base SX standard or 802.3z. This standard uses multimode and it can go up to 550 meters. Now the distance is calculated based on certain specs for fiber cables. You can get the specs of these cables from the documentation of IEEE or documentation of the manufacturer of the fiber or transceivers. The same speed, 1 gigabit per second, using the same standard can run over single mode, and in this case it is called 1000 base LX. Again, 1000 means 1000 megabit per second, LX means single mode, SX means multimode. And as you can see here, this single mode fiber can go up to 5 kilometers with 1 gigabit per second speed. Comparing this to 100 meters, that was the limitation for copper or UTP, you can see that fiber can go to much more distances than copper, and that's why fiber is used usually to connect different floors or different buildings in the campus, and in some cases fiber can be used for WAN links also. Next we have 10 gig fiber, and the standard for this 10 gig is 10 gig base SR. This standard is 802.3AE. It is for multi-mode and can go up to 400 meters. 10 gig base LR is single mode, can go up to 10 kilometers, and at the same speed 10 gig we have ER, which can run over single mode and can go up to 40 kilometers in distance. Now the specs are different and you should go for details to understand the difference between these cables and the requirements to reach these distances. There is another standard as 10 gig, which is not defined by IEEE, but it is proprietary for some vendors. This ZR standard, which is not IEEE yet, can go up to 80 kilometers. As this is not IEEE standard, you need to have the same transceivers from the same company in both ends, and they should support the same standard in both ends. Now let's discuss wide area network or WAN. WAN links usually go over long distance, which can be between different campuses, different cities, or even different countries. Typically, WAN links use serial links or leased lines, and they use encapsulation like HDLC, which stands for High Level Data Link Control, or PPP, which is point-to-point protocol. And currently, it is common to have WAN over Ethernet using standards like Ethernet WAN, Ethernet Line Services or E-Line, Ethernet Emulation, or Ethernet over MPLS. We will discuss some of these concepts when we discuss design in day 5 of this course. But in brief, the idea here is that service provider will use its cloud or its network to emulate Ethernet connection between both sides. So for devices at both sides, this link looks as if it is direct Ethernet cable between these two routers or these branches or these sides of the network. So at the end, all these technologies look like one Ethernet cable between branches or sometimes Ethernet cable between multiple branches, as we will see in discussing designs in day 5 of this course. When discussing WAN links and large networks, we usually use routers, and routers are used usually to connect WAN links between branches or different remote sites. In any network, every device has an IP address, and this IP address is used to route the traffic to different destinations over the network. Routers and IP addresses work at layer 3 of TCP/IP model, so it works at this layer of TCP/IP model, network layer, and if you remember, as we said in the previous slides, Ethernet works at data link and physical layer. So IP and routing works at network layer, which is higher layer in TCP/IP model. As we said before, every device in the network must have an IP address, and IP address is 32-bit binary, but it is represented usually as decimal dotted number like 172.16.01. This is IP version 4, and we will discuss IP version 4, IP version 6, and IP addressing in more details in day 2 of this course. That's all for LAN, WAN, and Ethernet. If you like this video and if you find it useful, please like, share, subscribe, and enable notification to receive future videos in my channel. Thank you and have a good day.